Hey guys, welcome back to our YouTube channel. So today we are going to solve the problem which is merge two sorted arrays. Okay, so what we are given is we are given two arrays which are sorted and we have to merge them, and we have to merge in such a way that the net array is sorted. Okay, so for example, we are given array 1 1 3 5 7 which is sorted, and another array 0 2 6 8 9, right? So what we have to do is we have to merge them. So the resultant should look like this: 0, 1, 2, 3, and then 5, 6, 7, 8, 9. Okay. And what is the condition here given is we don't need to use extra space. That means, so array 1 should look like this and array 2 should look like this. Okay. We don't need to have to create the extra or any third array. Okay. That is our question. Now let's think how we can solve this problem and what are the ideas and approaches for it. So we are given these two arrays 1357 and 02689. Okay. And we have to, these two are sorted, we can see, and we have to, merge it into a single one. Okay. Let's for now, for the naive solution, assume we are allowed to take the extra space. Okay. So what is the, most obvious solution can be, what we can do is create a third array and, insert both the array elements like 1, 3, 5, 7, 0, 2, 6, 8, 9. Correct. We can create a third array, and then what we can do is sort this array. So what we will get is 0, 1, 2, 3, 5, 6, 7, 8, 9 after sorting. Correct. And now we know, let's say, assuming this array has a length n and this is the length n. Okay. So what we will do is we will put first n element like 1, 2, 3, 4, that is first n elements into my A1 array, and then the remaining elements I will put in my A2 array, right? And hence I will get my answer. Correct. So this is the obvious solution, and talking about the time and space complexity, what I have done. Initially, I have created a third array and put all those elements, right? So it will be of n plus m, right? And then I sorted it. It will be something around uh, of n plus m log m plus n, right? And then again I have put a for loop and all those things. So on an average, the time complexity will be something like this. And the space, I have used an extra space which is of n plus n, right? So this much is the complexity of the naive solution, and obviously we know that this extra space that we are using is we should avoid, right? We should not need to do this. So let's think how we can make it better now. We have seen the brute force one, that is by taking extra space and then simply merging and sorting, right? Now what we have to do is think of something better, and for this time we don't need to use an extra space. That's what we are assuming, right? So what's the intuition now? Okay, as these array are sorted, this we have to use. Okay, so when I say the array is sorted, that means this 7 or whatever is the last element is the largest in this A1 array, and in this A2 array whatever is the first is the smallest, right? Correct. So what I can do, I can start from the last in this array and beginning of the second array, right? And compare these two, right? These two elements. So I can see that 7 is greater than 0. That means this 7 and this 0 are not at correct place, right? Because see, if I'm talking about sorted and in ascending order, that means whatever, if 0 is smaller, then it should be a part of A1 array, and as 7 is larger, then it should be a part of A2 array, right? Something like this. So what we will do is we will swap these two elements. Okay. That means instead of 7, we will put here 0, and instead of 0, we will put 7. Okay. And then we will move our pointers to the next element. That is 5 and 2. Now comparing these two, 5 is greater than 2. That means this 5 and 2 are not at correct place, right? We will swap these two. So what it will be? 5 becomes 2 and 2 becomes 5, right? Now, again moving our pointers. Now it is 3 and 6. So what it is? 3 is less than 6. That is the correct order of sorting, that 3 is coming first. So it is fine. We will leave this. Okay. That means we don't need to swap. What we will do? We will move to the next line, or maybe the next one. That is 1 and 8. Okay. Now, comparing 1 and 8. 1 is less than 8. The order seems correct, right? We will move to the next one. Okay. Now, and as this is done, so whatever remaining, or like whichever array is remaining, if one array is done like this, right? So we will put all the elements which are remaining of the other array, that is this 9. Okay. So this 9 we will remain as it is. Okay. Now what we have got, this array is like 1 3 2 0, and the A2 array is like 7 5 6 8 9. Correct. Now if we see, these two are obviously not sorted as 1 3 2 0, obviously not sorted, but we have separated out whatever elements belongs to which array. Now we know that all these elements will belong to A1 and all this belongs to A2. Correct? That we have find it out. Now what we can do is we can simply sort this array. So what it will become? 0 1 2 3, and it will become 5 6 7 8 9, right? So that's it. We have sorted our array without using any extra space. Correct? And so here the basic intuition was comparing the last element of the first array and the first element of the second array, because we know this one is the largest and this one will be the smallest. If they are at the correct place, we can start moving to the next one, here also the next one. That is the intuition. Okay. Now what is the time complexity here? Let's see. So what we have done is we are looping through this array and this array, right? That is of n plus m, something like this. And as what we have done is we have sorted these arrays like n log n, and this should be m log m. Correct? That's what we have done. And space, we are not using extra space, so it will be of 1. Okay. So this is one of the optimal solution. There is also one more optimal solution. Let's discuss this out. Now we have discussed one optimal solution. So a second approach of optimal solution can be something like this. Okay, listen carefully. So this approach is based on a famous sorting algorithm which is known as shell sort. Okay. In this algorithm, what we have is a concept known as gap. Okay. Okay. So here, assuming the length of this array is n, this length is n. Okay. So what does this gap? Gap is n plus m by 2, and whatever is the ceiling. Okay. We will take. Uh, okay. Whatever is the ceiling of n plus m by 2, that will be our gap. So in this case, the length of n is 4 plus m is 5 by 2, which is 4.5, and which is equal to ceiling is 5. Okay. So it means we have to place our two pointers at a gap of 5. Okay. So this is what a algorithm is. We are using a concept known as gap. Okay. So let's say I put it as here. Okay, so that means let me initialize, okay, my one pointer that is left from at the beginning, right? And the next pointer, my which is my right, should be at 5. Okay, that means 0, 1, 2, 3, 4, 5. Let's say here. Okay, this is my R. Okay, now let's see what we have to do. Let's start our dry run. Okay, we have to compare the L and R pointers. So 1 is less than 2, right? Seems fine. Like it is in the correct order. Now we will move our L to the next one, right? And also the R. We will move both one by one. Okay. Now again comparing, 3 is less than 6. Seems fine. Nothing to be done. They are at correct place, right? Now moving both L and R again. So it will be here and it will be here. Okay. This is my L. This is my R. Now 5 is less than 8. Seems fine. No issues. They are in correct place, right? Because see, if left hand side is less than the right hand side, that means we are correct. It is already in the correct order. Now going to the next one. Okay, 7 and 9 seems fine, correct. We can move. Okay, so the left will come here and the right we will reach the end. And whenever one of the pointers, and which is should be right only, moves to the end of the array, that means we are done with the current iteration. Okay, so our current iteration is done. Now this algorithm says we have to do this whole process again and again until we reach a gap of 1. Okay, and for the next iteration what we need to do is we need to divide our gap again by 2 and take the ceiling. Okay, so ceiling, that means something like 5 by 2. 5 is our previous gap, which is 2.5. That means 3. Okay, now what we will do is we will take a gap of 3. So that means again my left will be here. Okay, and my right will be here, right? Now let's start. 1 is less than 7. Yeah, seems fine. Moving to the next one. 3 here, 0 here. 3 less than 0. No, not fine. That means we need to swap these two elements. So what we will do is we will swap, right? Now going to the next one. Next is 5. It is 2. 5 is less than 2. Now we will swap. So 2 will come here and 5 will come here, right? Now moving to the next one. That is 7 is less than 6. Nope, right? That means 6 will come here, 7 will come here, right? Now what we will do? We will move to the here and it will come here. 3 is less than 8. Yes, seems fine. We will move here and it will come here. 5 is less than 9. Yeah, seems fine, right? Now if we move one more after 9, we are done, right? So this iteration is also done, correct? Now again calculating the gap, which is 3 by 2, which is 2, right? So my left will be here and my right will be here, right? Now doing our next iteration. Left is 1 and right is 2. 1 is less than 2. Yeah, fine. Moving to the next one. 0 less than 6. Yes, seems fine. Moving to the next one. 2 less than 3. Yes, seems fine. Moving to the next one. 6 less than 5. No, doesn't seem fine. So what we will do is we will swap these 5 and 6. Okay. Now what we will do? Move to the next one. 3 less than 7 seems fine. 6 less than 7 seems fine. 7 less than 8 also seems fine. 8 less than 9 also seems fine. Right? So this iteration is also done. Right? Now, again calculating the gap. What is the gap? 2 by 2, which is 1. Okay. Now we have reached 1, so this will be our last iteration. Again, this is my L, this is my R. Okay. Now, 1 less than 0. Now, 1 is not less than 0. What we will do? We will swap. So 0 will come here and 1 will come here. Right? Moving to the next one. Now it is 1 and 2. 1 less than 2. Yeah, correct. Now 2 less than 5. Next one. Yes, correct. Now 5 less than 3. Okay, what we are here is this is my 5 and this is my 3, right? No, not correct. Right? It is not. So what we will do is we will swap. 3 will come here and 5 will come here. Okay. Now next one is 5 less than 6. Yes, fine. We are comparing these two. Now 6 less than 7. Yes, fine. We can move forward. 7 less than 8. Yes, fine. Now 8 less than 9 seems fine. Okay. So iteration is done. We are done. Now let's see what are the arrays. We have A1 is 0, 1, 2, 3. This is my A1. And what is A2? 5, 6, 7, 8, 9. Right? So these two arrays are now sorted and in the correct positions also. Okay. So in both the optimal solutions, the difference is in the first one, we have to manually use the sorting of the each individual array. But in this, using the shell sort intuition by using gap, the end result will automatically be in the sorted manner. Okay. So you can use any of these two approaches. Both are fine. Like, there is nothing better or bad in this. Both the optimal ones are equally fine. Okay, if you tell anyone anything to your interviewer. Now, what is the time complexity of this? Okay, so what we are doing is we are looping through this, right? That is, we are having calculating a gap every time, and it will be, see, what we are doing is we are dividing by 2, right? That means whenever there is a division by 2, there is an algorithm of log base to n plus n. Okay, n plus n is my total length. And every time I'm literally iterating it, okay, in the inner loop. So it will be O of n plus n. Okay, that will be my time complexity. And space, we are not using anything, so it will be O of 1. Okay, so this is the solution or the approaches that we can think of and without using an extra space. So hopefully you have understood this approaches. Now let's go back to our code editor and let's start coding this. We are back to our code editor and now let's see what we are given. Okay, so we are given two arrays. We know array 1, array 2 and the size of the two arrays. Okay, and we have to change the arrays in place. Okay, no need to return anything. Okay, so let's start. We know what we need to do is we need to find the gap, right? And the gap is filling of, okay, whatever the length is by 2, right? So, and we have to do this iteration, okay. If gap is greater than 0, we will do our for loop or while loop and initialize our left pointer as 0 always, and the right will be always left plus gap, right? And then we will start iterating through our array and we will do till our you know, right is less than n plus n. Okay, we will do iteration. Right now, what is the possible case here? See, the only possible case, there are three possible cases. First one is that our left is in array 1, that means left is less than n, and right is in array 2. So right will be greater than equal to n. This is the one case. That means both our pointers are in different arrays. Okay. Another case will be if both the pointers are in array 2. Okay, that means the left will be greater than equal to n. Correct. And the third case will be when both are in the first array, that is array 1. Okay. So we need to swap, right? We will check the condition later on, or let's say because we know we need to swap. Let me write a swap function. Okay. Let's say it receives two array I and j are two pointers. Okay. What we need to check is if array of 1, that is I, is less than array of 2 of j, that means not less than, it should be greater than. Okay. If it is, greater than, that means we need to swap, right? See, if it is greater than, that means they are not sorted, right? So to swap these two, what we will do is we will just use a temp variable. Okay. And then start just, swapping to a temp variable. Okay. This is the basic thing. Okay. If they are not in sorted order, we have put the condition, then swap array 1 of an array 2, right? Okay, so what we need to do is we need to call our swap. If both the pointers are in different array, that means array 1 and array 2 we can pass, and first pointer will be left and the next pointer will be, it should be right minus n, correct? Because see, right can be, you know, right is combination of both the lengths, right? As we are doing this, right? So for the second array, we need to subtract n so that we can, choose the correct index from the right. Now, in the second condition, and just make sure to use this, okay? Because this is a class, okay, in JavaScript, and any function in class you have to call using this, okay? Now, for the second case, what we need to do? That means left is greater than equal to n. It means we are in the second array. Okay, so we know that both the arrays will be array of 2 where swapping will happen. And what is the left pointer here? Okay, so left will be left minus n and right will be right minus n. Obviously, because we are in the second array, so we need to subtract n every time. That is the length of the first one, so that we can correct the correct index, right? Now the third condition. The third condition is when both of our pointers, array left and right, are in the first array. So if it is in the first array, both will be array 1. And if it is in the first array, then it will be left and right, right? No need to do anything. Correct. Now, this is done. And after in while loop, what we need to do is in while loop, we need to uh, increment our pointers. Correct. So when this while loop is done, we what we can check is if our gap is 1, that means we are done, because after 1 we don't do anything, we can break from our for while loop. Otherwise we can calculate our new gap, which will be gap by 2 and ceiling of it. Yes, seems fine. So let's compile and run this and let's see. So yeah, it is compiled and run successfully. Let's submit this up. And yeah, so it is passed and submitted successfully. All the test cases have been passed. So if you guys have understood, please mention understood in the comment section. And if you guys have any doubts or any issue, just mention in the comments. I will try to help you out. And that's it for this video. We'll see you in the next one. Till then, bye bye. Take care.